In this video, I'm going to show you how to use integration by part to determine the integral of the inverse tangent of x. See how it's going to happen. The integral of the tan inverse of x dx. The integration by part formula says the integral of u dv is equal to uv minus the integral of v dv. Looking at this integral, at first it seemed to be that integration by part cannot be applied to evaluate the integral. But let's see if it will work. I'll say let u be equal to the tan inverse of x. So if I set this one to be u, what's remaining? Dx. So I'll say let the v be equal to dx. So u is tan inverse of x and the v is dx. So from here, if I differentiate u with respect to x, that means if I differentiate u with respect to x to obtain du dx, I will get differentiate the tan inverse of x to obtain 1 over 1 plus x squared. In one of my videos, I gave the proof for the derivative of the tan inverse of x, the sine inverse of x, and the cosine inverse of x. So you can watch to learn from scratch how to determine the derivative of the inverse tangent and the inverse cosine and the inverse sine. So this is it for the inverse tangent, okay? Now, to get v, this is du dx. Okay, from here, du is equal to, this is dx all over 1 plus s squared, right? I don't want to multiply this by this. So I just multiply dx by 1 and I got this. So du is equal to dx all over 1 plus x squared. Now, from here, if I integrate both sides, okay, integral of the v is v, integral of dx is x. It's as simple as this. So therefore, the integral of the tan inverse of x dx, the integral of the tan inverse of x dx, by the formula, says uv minus integral v du. So what's u? U is what? Tan inverse of x times what's v? This is our v, x, minus the integral of v, and what's v? X, times du. What's du? Du is equal to everything here. That's dx upon 1 plus x squared. So we have, okay, tan inverse of x times x, that's x tan inverse of x, minus the integral of x over 1 plus x squared dx. See the way I want to evaluate this integral. Just watch. 1 plus x squared is at the denominator. If I differentiate 1 plus x squared with respect to x, what will it produce? It will produce 2x. Yes. Differentiate this to get 0. Differentiate this to get 2x. That's with respect to x. 2x. Okay, I got 2x. What is at the top? X. So the difference between x and 2x is just the 2. So let me look for a way to make this one 2x. Yes. So I want to do something now. If I multiply this one by 2, I'll bring 1 over 2 down. See, 2 over 2 into the integral of x all over 1 plus x squared dx. So these 2 can go inside. Remaining 1 here. That's all. So that 1 plus x squared, the derivative of this with respect to s, is now equal to 2x, exactly what is at the numerator. And remember that if we take the integral of a function whereby the derivative of the bottom is exactly what we have at the numerator. This is f prime of x and this is f of x. So if I'm taking the integral of a function where the numerator of the function is the derivative of the bottom or the denominator of the function, the integral is simply the natural logarithm of the function at the bottom, f of x. So integrate f prime of x over f of x dx to obtain the lim of f of x plus c. Now this will say, if I take the integral of 2x over 1 plus x squared dx, it will be equal to this. X tan inverse of x minus 1 over 2. The integral of this is the natural logarithm, which is lim, of 1 plus x squared. 1 plus x squared plus c, since the integral is an indefinite integral. So this gives the integral of the tan inverse of x using the technique of integration by parts. I hope you enjoyed the video. Keep supporting by subscribing to this channel, like and share the video to your friends and to your classmates. I will see you in the next one.